So Janta, welcome once again to my channel Puzzle Pandit. I am Manoj Singh and today I am here with this Sudoku invariant puzzle. This is called as a circuit sum or known as circuit sum, and this is by Ridhwan. And if you look at the puzzle, this looks like those electronic circuits where these may be the connections. And if you have looked motherboard or the motherboard diagrams or any circuit diagram, that kind of similarly looks like this. So maybe that's the reason this is named as circuit sum, and this is by Ridhwan. So let's read the rules. So clearly normal Sudoku rules apply. That means each row, each column, and then each 3x3 box contains the digit 1 to 9 only once without any repetition. So about the blue lines now, digits at the endpoints of each blue lines are the same. Okay, so for each line, the endpoints, they must have the same digits and indicate exactly how many unique digits are on that line, including those endpoints. Right? So, so the number in these endpoints must be the same as the number of unique digits here. So, let's say if this is like I don't know how to put that. So 2. Okay, let's change this to small. So 2, 3, 4. Where is it? 4, 5, 6. So now how many digits are there? 1, 2, 3, 4, 5, and then 6. So this must be 6. So something like that. So let's change 6 to 7. So now how many different digits we have? 1, 2, 3, 4, 5, and then this will be 6. So this will be 6. Let's say instead of this 5, if you have 4, then this both will be 5, because now you have 1, 2, 1, 2, 3, 4, 5. Oh, sorry, including this, right? So that will be 6, right? Because now you have 1, 2, 3, 1, 2, 3, 4, and 5, right? So this will be 5. Yes. So that's correct. Because including this, you should have 5 different digits now. So you have 2, 3, 4, 5, and 7. 2, 3, 4, 5, and 7, right? 5 different digits you have, 2, 3, 4, 5, and 7. So that's correct. And if you change this 4 to something else, then this will become 6. So that's how this works. Blue lines are also region sum lines. Box borders divide the blue lines into segments with the same sum. So these blue lines are also called as region sum lines. So region sum lines is a kind of standard invariant. That means whatever the sum of this much part should be same of the sum of this much part, because this is the same line, and whichever box it goes through, they should have the same sum. So maybe it's clear to understand here. So whatever is the sum of the red digits should be same as the sum of the green digits must be same as the sum of the yellow digits, right? So if you look at this line, all these sums should be same. So that's the rule. So these blue lines now have two purposes. Either of course this endpoint should be same. The endpoints must be the number of unique digits on that line, and then again it's also the region sum line. Digits joined by a white dot are consecutive, right? So white dots we have seen. There is also one horizontal dot and two vertical dots. So digits around it should be such that they should be continuous digits. So if you have 2 here, so if you have 2 here, you must have either 1 or 3 here, like that. You cannot have any other digits. So something like 4 here and maybe 7 here is not allowed, because it should be continuous. Not all dots are given. That means there is no negative constraint. Clearly means anywhere else there is no white dot does not mean that they cannot be continuous. They can still be continuous. So for example, these 2 digits, right? You can have 2 here, you can have 3 here, even though there is no white dot between them. That's possible. So those are the rules. So of course these lines, I have seen this one earlier, but I didn't have it on my channel. So I thought that this is a good puzzle for a channel, and also it has a difficulty as medium difficulty, 3-star difficulty, and I think 93% of rating. So yeah, people have liked this puzzle. So I thought this is a great, this is a good addition for the channel by Ridhwan. So I'll start this, and I hope you will also give it a try and you will be able to solve it. And if you stuck somewhere, you can come and watch the video and see if this helps you. And then again, before starting, again another request that if you have any puzzle, any puzzle, Sudoku or anything like that which you need help to solve it, you can request, and I'll try to solve it on my channel. So with that, let's start. And first thing I am noticing is this one, right? Now we know that this is region sum. That means clearly the sum of these two must be same as sum of these two, and we also know that these two are same, right? And these two must be the number of unique digits on this line. So I think there are only two unique digits on this line, and so that means this must be two. That's clearly because this must be same as this, or that then only the sum of these two must be same as sum of these two. So clearly there are only two digits on this line, and these two must be same. And if this is green, then green is somewhere here along with 2, right? 2 is also somewhere here. Clearly that can't be 2, right? You cannot have, you minimum have 1, 2, 3, 4, 5 different digits here, so that can't be 2, but that could be green. We don't know what is green, could be anything, right? Yeah, let's come to this line now. So this is what? Maximum 1, 2, 3, 4, 5. 5 minus 4. So this is between 3 and 4, right? So maximum this could be 4, isn't it? 1, 2, 3, 4, 5. Right. So the maximum length, right? I mean the maximum digit on this line must be the length minus 1, right? Because these two are same. So, and that must be 4, right? And what is the minimum? Minimum is 3, right? 1, 2, 3. So this could be between 3 and 4, but yeah, but then again region sum rules come into picture, right? Considering these two are same, right? Now the sum of this one should be same as the sum of these two, right? So right, so these all should be different, right? So 3 is not possible. 3 means, now think about this, right? If there is 3 here, that means this digit must repeat somewhere here, but that's not possible because this must be the sum of these two. And so if this digit is repeating in anywhere else, so the other digit on this line must be 0. So that's not possible. So clearly all these are different, and that clearly means this one has to be 4. You can remove the coloring part. Yellow and blue we can remove, right? 2 is still here, right? 2 is still possible here. Okay. So this is about that line, and then we know that this digit is sum of these two digits. Let's look at this line now. Now this line is 1, 2, 3, 4, and also this is clearly 5, right? There is no other option here. Would it be 4? 1, 2, 3. So this must have 4 different digits definitely, and then this is different than all of these 4. So this must be 5. Can it be 4 is I am thinking, because if this is 4, right, that means this digit is repeating here. That's not possible, and this digit is repeating here, but we know that these both are same, so that's not possible. So clearly this is 5, and the sum of these 3 now must be same as this. So that means this must be 6, 7, 8, 9, right? Because the minimum, now the digits you can put here is 1, 2, 3, which sums to 6. So this must be 6, 7, 8, 9. Minimum here it could be 6. It cannot be 5, it cannot be 4, because then you do not have 3 digits which can sum to 4. 3 different digits which can sum to 4. You can have 1, 1, 2, but that's not allowed here, because these 3 must be the 3 different digits. That's clear. So we got 5, we got 2, we got 4. What about this line now? Right, so what is the length of this? 1, 2, 3. So minimum this must be 1, 2, 3, 4, 5, right? Minimum this must be 5, and maximum 1, 2, 3, 4, 5, 6, 7, 8. Maximum this must be 7, right? And this cannot be 5. Okay, let me just disable this auto thing, right? What is that? Check pencil mark. Okay, check pencil mark. I will off. So clearly this is not 5, because 5 is already looking at this. So this is between 6 and 7. 6 and 7. 7 means all these are different, right? Now, yeah, this cannot be 2 now, right? Because this digit, right? Now let me get rid of. Yeah, let it be there, right? So that means this digit must sum to these two, right? because this is region sum line, sum of this must be same of sum of this. But considering this digit is same, clearly sum of this must be same as sum of this. I mean, these two should sum to this digit, so this cannot be 2, because if this is 2, those both must be 1 1. So that's not 2. So definitely we got one more digit, which is 2 here. And now 2 is not green, so we can remove green from here. One of this is green, but this is sum of this, right? So it could be 3, 4, cannot be 4, 5, 2, but it could start with 3. But 3 is different, right? Because yeah, right. And also this digit is somewhere here, right? So if this is pink, pink is somewhere here. So what does that mean? So now this cannot be 7, right? Because we know that this one digit is definitely repeating here. So this has to be 6 now. 7 means all must be different, right? All must be different. But now we know that this digit is definitely here by SUDOKU. I mean, think about this, right? Where is this digit going to go in this box? It cannot be here by SUDOKU because of this. Cannot be here. Must exist on this line. So clearly this must be now 6. It can't be 7. So that's 6. We got one more digit here. This could be 6, right? Okay. 6. This must sum to this. So this now this should be more than, it can't be 3 now, right? Because yeah, now think about this, right? This should also be sum of this, but we know that 6 is somewhere here, right? Now let's get rid of this color also. Less color better. So we now know that 6 is somewhere here, right? And the sum of these two must be same as sum of this. That means the other two digits on this line other than 6 or this quotient must sum to this part, right? So if it is 3, this will be 1, 2, 3, right? But then what are these two digits? That those should also sum to 3, which is 1, 2. So whatever this get here will repeat here. So let's say, so this will be 1, 2, this will be 1, 2, 6, and that will be 3. But now because of 1, 2 here, you cannot have anything here, right? This 1, 2 will not be possible here because you already have 1, 2, 6 here. That means I think same with 4. So this is minimum 5, because this must be some digit which have two different sum. So 5 has two different sum, 1, 4 and 2, 3. But 5 is already here, so as 6. So this must be something more than, so this is 7, 8, 9. This must be 7, 8 or 9. Right, I think that's only we can do. Yeah, 6 is looking at here, so that cannot be 6. This is 7, 8 or 9. So this one is again 6, 7, 8 or 9, right? Yeah, that's correct. We don't know which one is this, right? Could be any of this. I'm just thinking about this. Can we figure out this? For example, if this is 7, what will be here? This must be 2, 5, 6, right? Because it cannot be 3, 4, it cannot be 1. 7 only have 3 pairs. I mean, 7 has 3 pairs, 2 digits pair, which sums to 7. It is either 3, 4, 1, 6 or 2, 5. But because 6 is here, we cannot use 1, 6. 4 is here, we cannot use 3, 4. Yeah, right. So I don't think at this stage I don't think we are at the stage where we can figure out what is this, because even 9 has a lot of options here, right? So so yeah, maybe let's think about this line now. Yeah, so minimum this is 1, 2, 3, 4, 4, and maximum 4 and 3, 7, right? So 6. So this is between 4 and 6. So 4, 5, 6, right? And all are looking here. Okay, what does 4 mean? 4 means these 3 digits. I mean, whatever these 3 digits, 2 are repeating here, which is not possible, right? So 4 is definitely not possible, because 4 clearly means these 4 digits only repeating here. But considering these 2 are same, then 2 of these digits must be here. But then if you see, right, region sum line, these 3 digits, right, must sum to these 2. So that's not possible. I mean, then the third digit here is missing. If this would have been 3 lines long or 3 digit long, you could have said that is fine, but that's not fine. So no, because that is only 5 or 6. So 6 means everything is different. 5 means one of these is repeating here. Yeah, one of these is repeating here. So yeah, that looks fine. Alright, so now that leaves us with this big line. So we know that these two are same. And again by Sudoku, right, this must be here. And the sum of this, right, must be then sum of these two, and then whatever the next 2 digits must be sum of this. So it's kind of similar to this line. Maybe I can now remove the yellow color. Alright, so sum of this, no, so this digit is sum of these 2 digits, and whatever the 2 digits here are, those also sum here. Right, so if these two are same, that will be 3, 3 and 1, 4. So minimum these are 4 and maximum these are what is the length of this line? 3, 3, 6, 2, 7. So 4, 5, 6, 7. Why I said 4? Because 3, yeah. What I am saying is these 3 digits are repeating here, and then that's a different digit. Yeah, because this must be, this cannot be anywhere, right, on this line, because this digit must be different than this digit, and then this digit is also the sum of 2 digits which are here and here. So this is definitely different digit. That means clearly this digit now exists somewhere here, right? Or maybe it could be this one, because this digit now cannot be here, or whatever this cell is, it cannot be here, it must be here. So it must be somewhere here. I don't think that is helping. 7 is all are different, right? No, but 7 is also not possible, right? Because we know that this is similarly here, right? We know that one of these is definitely repeating here. So 7 is gone. 7 is not possible. So maximum 4, 5 or 6. What does 4 mean? 1, 2, 3 and 4. So these 3 repeating here. And what does 5 mean? So this digit is here, and the sum of these must be this. So this digit is not repeating here on this line, and not here in it. So we already have 2. These 2 are different, which is 4, and those could repeat here. So 4 is fine. What is 5? 5 is not possible, right? I can't think of 5. Yeah, 5 is not possible. 5 means these 2 are same, which is repeating here. This digit is different, but that means the 2 digits here, they are either different or either same, right? It's not possible that other than this digit occurring here, right, the other digit, I mean the digit which is not pink on this line and here. Okay, let me explain with the color. So let's say this yellow is here. Now you just cannot have one yellow here, right? You must have either both yellow here or no yellow here, because this also must sum to these 2. If there is one yellow here, both will be yellow here, or otherwise there is no yellow here. So 5 is not possible. 5 is not possible because of that. Because 5 means only one of the yellow is present here, but that's not possible. Either both yellow should be present here or none of the yellow should be. So only 4 and 6 is possible. fact 4 is also not possible, right? Because if you see that, so that I think that's okay. So that's how this is meant to be seen. I think we should have started with this line itself. Yeah, yellow is not possible because now imagine if yellow is here, right? So that means yellow is somewhere here, right? It doesn't matter where. So now this itself consists of all these three digits, right? But now where are these three digits here, right? So something like roping, or roping is something like roping is going on here. So these three digits will be here. So now where will be these three digits in this box, right? These three digits cannot be here. Again, it cannot be here because of this, cannot be here, cannot be here because of this, cannot be here because of this. So it must be here. But now we know that this digit is definitely different than all of these digits. So that means both yellows must be here. But that's not possible. I mean, you cannot have these two digits simultaneously in this single cell. That's not possible. That means these are different digits than the yellow, and that clearly means this is 6. This cannot be 4. This has to be 6. This is 6, and these two digits are different. That again means this is 7, 8, 9, because this sum must have two different, at least two different sum. So it cannot be 3. You cannot have 1 2 1 2 here. It should be minimum 2. I mean, minimum 2 sums must be possible there for 2 digits for this number along with 6, other than 6. So 5 is already gone, 6 is already gone, this is 7, 8, 9, and look, we got triplet of 7, 8, 9. So this must be 1 3 4, right? Let's do that by simple Sudoku. These are 6 7 8 9. Oh, but look, 6 is looking at here now, so that must, these both are 5. And what does 5 mean here? 5 means one of these digit is repeating here. Okay. So this is 6, this is 5. Does this 5 help somewhere? 5 is one of these two. 5 5. Oh, lot of 5s here. Can we? That can be 5, right? Because we know that that is one of these. Oh, and this cannot be 6 now, right? So this must be 7 8 9. This cannot be 6 because of this, right? So this is not green. We now know that this is definitely green. So these are 7 8 9 7 8 9. This is blue. Now is it kind of coloring puzzle where you color 7 8 9? Maybe, I don't know. Maybe this one. See, this sum should be different than this sum, right? So if this is 7, the only possibility here is 3 4, right? And then this is not possible, right? See, because now we know that this sum, I mean, these digits must be different here and different here, and they should sum to this whatever number is there. So if this number is 7, the only possibility here is 3 4, right? Because you cannot have 1 6, you cannot have 2 5. So only possibility is 3 4. But now what are you going to have here? Because 6 is already here, you cannot have 1 6. You cannot have 3 4 because 3 4 is already here, and you cannot have 2 5 here because of these 5. So 7 is not possible. I think same goes with 8. Let's check. So that means this must be now 1 7, because it cannot be 2 6, it cannot be 3 5. It must be 1 7. If this is 8, this must be 1 7, and now this must be something different than 1 7. So it cannot be 1 7, it cannot be 2 6, and it cannot be 3 5 because of this, right? So this is not it, and that means this is only 9. 9 is the only possibility here. Both these 9 are not there, and that means this 9 is also not there. So this is 7 8 7 8. 9, and now can we get it? This must be 1 8. It cannot be 3 6, it cannot be 4 5, it cannot be 2 8 2 7. So this must be only 1 8. Correct? Let me check again. It cannot be 3 6, it cannot be 4 5, it cannot be 2 7. The only possibility is 1 8 here, and that means these all are 7, because 1 8 looking at here, this must be 7, and that means this is 8. 8 means this must be 1 3 4 now, right? Because the only two ways to create 8 in 3 cell is 1 3 4 or 1 2 5. but 5 is already there, so this must be 1 3 4, and 4 is not here by Sudoku. Now these digits also we can figure out, right? We know that 6 is definitely there. So when 6 is definitely there, this cannot be 1 8, it cannot be 3 6, it cannot be 4 5, this must be 2 7, so this must be 2 6 7. Yeah, this must be 2 6 7. We can now get rid of colors. In fact, we can get rid of 9. Wait. So 9 is somewhere here, right? And 9 is somewhere here. But important is 9 is somewhere here. That's not blue. Let's get rid of colors. Here also we can now get rid of colors, right? We have done with green. 2 6 7. There are a lot of options here till now. Yeah, what next? Oh, this dot is limited now, right? I mean, this must be continuous, right? Right. And the way to think about these dots, right? It must have one odd and one even number, right? Because these are continuous. So which is the even number here possible? 2 is not possible. 8 is not possible. 6, if you take 6, right? Then it must be coupled with either 5 or 7. But both 5 and 7 present here. So 6 is not here. That means only 4 is possible here. And that means this is not 4. But if you even think further, right? 4 could also either be 3 4 or 4 5. But 5 is here. So that means this only 3 4, and that means this is 1. No, that's 1. And now I think some kind of now some roping is going on here. 1 3 4 1 3 4. This must be 1 3 4. Now remember, sum of this must be sum of this, and one digit from here is common here. 5 to 7, right? And now roping is going on, right? Roping means what happens is that if any one column is like repeating here, the others also just simply repeat like that. Because now think about here, right? 5 to 7. Now 5 to 7, where is in this box? 5 to 7 will go. They cannot be here. They cannot be here. They must be here. So this is 2 7. Clearly these two are 2 7. And the other digits now you can simply put right from here 1, or maybe here, right? 1 2 3 4 5. This must be 6 9, right? The only remaining digit, and in fact 6 is looking at this, so that's 9, and that's 6. 9 9. But that means this is also 6 8 9, right? 6 8 9, and we know that that can't be 6. Because of this 6 8 9 6 8 6 9, and that is this is 6 8 9, isn't it? 6 8 9. And this must be 8 9 8 9, right? Because I don't think 6 has anything to do here on the dot. That means this has to be 6. So we got 8 9 8 9. We got 6. So that means this cannot be 6. This is 2 or 7. 6 is one of this. That 6 is also difficult, right? Because that means this must be 7 or 5. But considering 7 is here, 5 is here, so again that cannot be 6, and that means only this is 6. Right. So now 6 we know that must be here. Clearly, both these 6s are not possible, so that has to be 6. And this must be now 2 5, right? Because the other two must sum to 7. And 7 you cannot be, that cannot be now 1 6, that cannot be 3 4. The only possibility 2 5, and now we know that 5 is here, 5 is here, and 2 is here. That 2 means this has to be 7, this has to be 2. This could be 1 or 3. Is anybody seeing 1 or 3? No, this has to be 1 or 3. This one now, this one should also be 7, but it cannot be 2 5, right? It has to be 3 4, and look, 4 is looking at here, so that means that is 3, that is 4. This 3 4 looking at this, so that's 1. Now that's 1. That one looks at here, so that's that's it, that's one. mm, One is somewhere here. 134 134, these three digits, right? It must be 1 2 3 4 1 5 8, and it's not resolving. 1 5 8 1 5 1 3 2 1. So we got 1 here, and we got 2 7 or 6 8 9 here. And we know that one of these digit must be repeating here, and the other must be sum of the other two. So these digits are now 3 4 9, right? 3 4 9. So 9 is definitely here, and one of 3 and 4 is there. So in fact this is not 6 now, right? And 6 is here. So that is 8 or 9. 8 and 1 could be 9, but then 2 and 7 must be repeating, but it's not possible, right? Right, and 3 and 4 is not here, that means the repeating digit is 9. See, one of these digits, because of 5, right, we know that one of these is repeating here. Now which one that is that? 3 4 9, none of this is 3 4, the only possibility is 9, because even 2 7 8 1 2 7 8, right? None of this is here. The only repeating is, I mean the only common is 9, so this has to be 9. And now the other must be the sum of these two, because again the sum of this must be same as sum of this. Now we know that 9 is common, the other two digits here must be sum of the other digit here, and the only possibility is 3, which is with 1 2. So this has to be 2, and 4 is not here, that's 3 9. Is anybody looking at this 3 or 9? Any of 3 or 9? But 3 or 9 is here, that means 4 is here. With 2 can we do something? Yeah, 2 is looking at that, so that's 7. 3 4 3 4 8 9, so 9 has done, so that's 8. 2 7 2 7 1 3, oh 2 is done, so that means that's 7, that's 2. 3 1 3 1 3 is still like that, right? Oh, this line now clearly, let's just put the numbers here. What is the possibility here? 1, sorry, not here, only here. So this is 1 2 3 3 4 5 6 7 8 9, 2 3 4 8 9, and this is 1 2 3 4 5 6 7 8 9. But now look, this number must be 2 plus this number, right? So 2 is definitely not possible, minimum this must be 3, and also 8 is not possible because 8 plus 2 will be 10, which is not available here, so that's not. 4 is not possible, right? Because then again this will be 2 plus 2, so 4 is not here, and now I can't see any 6 here, that means 4 is also not possible here. So 8 is also not possible, right? Because I can't see 6 here. So 3 9, and I can't see 5 here, that means 3 is not possible. So this is either 1 5 or 3 9. 1 5 or 3 9. Any 3 or 9? No, none of 3 or 9 looking at. Okay, so now it is pure Sudoku, right? We have done all the things. Yeah. So what is this digit? These two digits, right? 1 2 3 4. Those are 5 and 7, right? 7 is looking at this, so that's 5. That's 7. That 5 now gives 5 here. Now that's 5. In fact, this 4 is looking at this, so that's 3. 1 8 1 8 3 4 3 4 1 5 3 4. These two digits, right? Those are 1 2 3 Oh, 2323, right? So that means that has to be 1. That can't be 1. 348939. That's 3489, isn't it? See, 4 digits are remaining, right? 1, 2, 3, 4. And those all must be now 3489. 3489. But look, 34 is already there. That means this has to be 89. 8989. Now we got this couple 89. That means 8. Both these 8 and 9 must reside in this cell and they cannot be in another cell. That means this has to be 3. We can get rid of 9 from here. This has to be 4. That can't be 4. This is 1313. Is 4 helping here? No. But this 3 means now we know that this must be 1 because this must be whatever 3 minus 2. So that's 1. That gives 8 here. That gives 1 here. 3. Yeah, this 4 now gives us 3. That gives us 4. And 3 corner 3 party to net. I think we are on the right track. 8 9 8 9. These 2 now, right? 1 2 3 4. But clearly 4 must be here because of this, and this is 8. So only remaining digit that gives 9 here. That gives 8 here. That gives 9 here. That 9 gives 3 here. That gives 9 here. That 3 gives 1 here. That gives 3 here. This one, right? This is single digit in this column. So 1 2 3 4 5 6 7. I think 7. These 2 digits now also remaining, which must be 1 and 8. 1 8. But look, 1 is here, so that means that has to be 8. That has to be 1. These 2 digits now, right? 1 2 3 4 5 6. This must be 8 9. Unfortunately not resolving it. And this is 1 2 3 and something. 3 and 5. Yeah, 3 and 5. But that is resolving because this is 5 here, so that's 3 and that's 5. 8 9 8 9 is not yet resolving. Anything here is resolving. 4 9 6 7 8. No, 2 3 3. No. So what is that now? 1 1 1 must be somewhere here, right? But look, 1 is here. That means 1 has to be here. And now that digit is 8 9. These 2 digits are now 1 2 and something, right? 2 and 5. Is that correct? Yeah, 2 and 5. But 5 is here. That means this has to be 2. This has to be 5. These 2 must help somewhere. That's 3. That's 2. This 3 also helps here somewhere. That's 4. That's 3. That 4 helps here. That's 9. That's 4. That 9 helps here. That's 8. That's 9. That 9 gives 8 here. And what is this now? 1 2 3 4 5 6 7 8 9. And 1 2 3 4 5 6 7. Is that correct? Yeah, and that's how the puzzle is solved. Yeah, so I think this was a good puzzle with the circuit sum, a new idea of this circuit, a double meaning for this line. Double meaning in the sense 2 meanings or 2 options for a single line. You can have it in 2 ways. So I think this was a good puzzle, and yeah, I mean nicely put, right? Especially I like this line, the logic of this line, that this has to be separate digits, otherwise this will be, I mean this digit will have to be both of these digits, which is not possible. So yeah, so nicely the ideas of Sudoku were used in this puzzle, and also this one, right? The single even digit was only remaining here, which is 4. So yeah, this was nicely thought of and nicely built up around this circuit sum. So yeah, I hope I'll see more of this circuit sum rule in the future, because I think I have understood how does this work, and then we can have it go with you. So yeah, so let me know in the comment that did you enjoy this puzzle, and were you able to solve this puzzle, or you think that I mean you are not interested in this this circuit rule. I don't know. I mean, I like it, but yeah, anyway, it's a choice of individual. So anyway, that's all for now. Thank you very much, and have a good day.